Alright, now let's actually use the Pythagorean identity to help us solve some trig problems. So what we're going to be given in these problems is very limited information. We're going to be given either the cosine value or the sine value of a particular angle, and we're going to be given the location of the angle in regards to which quadrant it is. So we'll be told that if our angle was in quadrant 1, quadrant 2, quadrant 3, etc. So here in this first one, what we're told is our angle theta is in quadrant 4. And what we're told is the cosine of that angle theta is 9 over 19. And the question is, can we use those two pieces of information to figure out exactly what the sine of that angle would be? So to help us do this, we're going to set up the Pythagorean identity. So we've got cosine squared theta plus sine squared of theta equals 1. So the first thing I'm going to do is plug in that cosine of theta. I know that to be 9 over 19. So 9 over 19 squared plus sine squared of theta equals 1. So I'm going to solve this for sine of theta. So first thing I'm going to do is subtract 9 over 19 squared from both sides. So I get sine squared of theta equals, and let's see, I'll show you how I do this in the calculator. So I do 1 minus alpha y equals 9 over 19 squared. So I do 1 minus 9 over 19 squared. Enter. So I get 280 over 361. over 361. So I want to know what sine of theta is. I know that sine squared theta is 280 over 361. So what I can do at this point is square root both sides. I'm going to continue up here. So I've got sine of theta equals plus or minus square root of 280 over 361. So the question now is it positive square root of 280 over 361, or is it negative square root of 280 over 361? And this is where the location of our angle comes into play. Since it's in quadrant 4, remember what we know about quadrant 4, y values there are going to be negative. Y values there are going to be negative. Imagine any point in quadrant 4, the y value of that point is going to be negative. So remember, those y values, those match up with our sine values. So final answer for this, since that angle is in quadrant 4, we're going to go with the negative square root of 280 over 361. So we're not going to include the positive version since our angle is in quadrant 4, which means this value has to be negative. So we're going to throw out the positive value. Alright, let's see how this plays in a different quadrant. So in the next example, let's say this is what we know. We know our angle is in quadrant 2 this time, and we know the sine of that angle. We know it to be 1/3. 1/4. So we got an angle, it's in quadrant 2, and we know the sine of that angle. So the first thing we're going to do is set up our Pythagorean identity. Cosine squared of theta plus, this time I know the sine value, and it's 1/4. So I'm going to do 1/4 squared equals 1. So I'm going to subtract 1/4 squared from both sides. So bring down my cosine of theta. So in my calculator, I'm going to do 1 minus negative 1/4 squared. So I get 15 over 16. Now I'm going to square root both sides. Since it's being squared and I want to figure out what cosine of theta is, I'm going to square both sides. So cosine of theta equals plus or minus square root of 15 over 16. So now I have to pick which one is it. Is it positive square root of 15 over 16 or is it the negative? So let's think about what we know about points in quadrant 2. Particularly since we're dealing with cosine here, let's think about what we know about x values in quadrant 2. So every single point on the left side of our coordinate plane is going to have a negative x value. Particularly in quadrant 2, every x value, and therefore every cosine value, is going to be negative when we're dealing with the second quadrant. So our answer for this one is going to be negative square root of 15 over 16. Because we're dealing with quadrant 2. Cosine values over there have to be negative.